Welcome to Hypothesis Tests on the TI Calculator. You should get pretty familiar with that Stat button by now. That's what we want to do. Turn your calculator on, press the Stat key, arrow over to Tests. Now, we're going to do 3 types of hypothesis tests in this class. The least frequent is the Z-test, which is choice number 1 on your calculator. That's when you've got a normal random variable and you know sigma and you want to test for the mean. Highly unlikely. The test we do most often is the t-test, choice 2, and it doesn't much matter if we have a normal random variable or not, but we don't know the population standard deviation. We do not know sigma. And the third test we're going to do quite often is using proportions. That's choice 5, 1 prop z-test. That's the one I warned you to stay away from in the last chapter when you were doing confidence intervals. But now we're going to use it in hypothesis testing. If you go to any one of those, this is what your screen should look like. Notice the proportion test has the least to put in. So let's do a proportion test. Let's say we've got a test where we think people can extend their life. Number 24 in the book. Can individuals temporarily postpone death to survive a major holiday? Studies show 6,000. You know what, I'm going to write this all out. Welcome to Hypothesis Tests on the TI Calculator. We should be pretty familiar with that Stat button, and arrowing over to Tests should be no problem for us. When you get there, there are 3 hypothesis tests that we're going to run in this class. The least frequent will be the Z-test. That assumes we know our population standard deviation and we want to test the mean. Highly unlikely. But if that's what we want to do, we want to choose choice 1, the Z-test. If, on the other hand, we're doing a test on the mean and we don't know our standard deviation, that would be quite common, and we want to do choice 2, the t-test. We also are going to do a lot of proportion testing. Recall choice 5, 1 prop z test. I warned you away from that one when we were doing confidence intervals, but now that we're doing hypothesis tests, that's a good button to know. If you press any one of those, these are your choices. The z-test, you have to tell it the mean of your hypothesis test. You have to know your population standard deviation, you need a sample mean, the size of your sample, and this row right here, that's your alternative hypothesis. If your alternative hypothesis is mu unequal to some value, you would choose this one. If your alternative hypothesis was mu less than some value, you would choose the next one. If you have a right-tailed test, your alternative hypothesis is that mu is greater than some value, you do this last guy. The t-test, they're in a slightly different order. Again, this is the hypothesis test mean. You need a sample mean, a standard deviation, sample standard deviation, sample size, and then again, these are the alternative hypotheses. The proportion test, you don't need so much information. You just need to know that hypothesis test proportion value, number of successes, a sample size, and again, your alternative hypotheses. Sometimes we're given a situation where we just know our sample proportion. We don't know the x and the n, but we always know n. So if you had a sample proportion, you could type that number in and multiply it by your sample size, and that would give you the x value. Now be careful, if your sample proportion times n doesn't equal a whole number, you'll have to round to the nearest whole number. Well, nearest interval? No, nearest integer. Since that proportion one uses the least amount of information, let's just do one. Can individuals temporarily postpone death to survive a major holiday? A study showed 6,062 deaths before Thanksgiving, 5,938 after. I don't know about you, but Thanksgiving isn't a major holiday in my life. I would try to survive a wedding or Christmas. Who cares? Thanksgiving? Well, anyway, if individuals can postpone death, then the true population proportion should be less than 50%. Use a 0.5 significance level to test this claim. Okay, what's our hypothesis? We've got a null hypothesis and an alternative hypothesis. My null hypothesis is not my claim. The claim says less than 50%. That does not include the equal sign, so my proportion less than 0.5. That means my null, the proportion is 0.5. Now what's the information I've got here? I know my sample size, it's going to be the 662 plus the 5938. That's 12,000. That's N. The people that were able to postpone their death and make it through Thanksgiving, that's the X. That's the 5938. And that's all we need to run a proportion test. So I'm going to come up here and enter my hypothesis of 0.5. I'm going to enter my X of 5938 and my N of 12,000. And we said we were claiming our alternative hypothesis was greater than the p-value. And we hit calculate. What does it tell me? It tells me I'm testing for a proportion less than 0.5. It tells me the test statistic is a negative 1.1320 if I rounded to 4 decimal places. It tells me the p-value. That's 0.1288. And it tells me p-hat. That's x over n, 0.4948. And it tells me n. What does this mean? Well, we have a set of P statistics and we have a set of T statistics. We were betting that P was 0.5. That would be 0 on the t-axis. We found, I'm sorry, getting ahead of myself to my next example. We have z-scores and p's. We found the z-score to be negative 1.1320. We could calculate a p-value. This is our test statistic, and so this area from the test statistic on is our p-value, 0.1288. We were using a 0.05 confidence interval, hypothesis test, and the 0.05 would have been out here somewhere. That would be my critical point. Because alpha, the level of significance, is 0.05. This is my acceptance region. I am going to accept or fail to reject my null hypothesis. I cannot support the claim. I see no reason to believe people can extend their life. That's my decision. We failed to reject the null hypothesis. And that should do it for hypothesis testing with proportions. I'll start another video to do hypothesis testing with the t-statistic.